那所以要报告的学生是谁？
对，报告学生是有一位外籍生，
艺名是？
叫做那个欧贝阿迪库苏嘛。那他主要会针对他这次500吨要进行的试验，或做一个简单的报告吧。
那所以你怎么样？So Obeda, right?
对。
So Obeda, are you ready for the presentation?
Hello everyone, yes, I'm ready.
Okay, so can you open your file and share to the people?
Okay, sure, thank you. Can you see my slide?
Yes.
Okay.
Yes.
Okay, thank you. Okay, good afternoon, everyone. Today I would like to present about the test program of SRC columns generated by the FWSCT under 4-point bending. So my name is Obed Adikusuma with the student ID of M1015012, and my advisor is Professor Chung Seung Lee. So this is the outline for today's presentation. So the first section will be about the introduction, and the second section will be about the test program, and the last section will be about the moment curvature analysis. I will start from the introduction. So as can be seen in figure 1 and figure 2, this is typical configurations of SRC columns. So as we know that SRC columns has been widely used due to some advantages such as high load carrying capacity, stiffness, ductility, and energy dissipation capacity. Previous research conducted by Lai et al. In 2019 shows that the steel flange as well as the steel web in SRC column contributes to the confining pressure acting on the concrete. As we can see in figure 4, for partially encased, the strength enhancement ratio, or the FCC over FC, is plotted as the functions of steel area ratio, steel contribution ratio, as well as the width to thickness ratio of the flange and the web of the sheet steel. Another research conducted by Chen et al. In 2018 investigates the seismic behavior of the SRC column. As we can see in figure 6, the hysteresis curves of Z1 and Z2 are stable and white plumb, indicating that the specimens have good seismic performance. However, according to AISC 360, the SRC columns need to have additional steel rebars to confine their cross-section to meet the requirements of the axial strength and seismic resistance. Of course, this required steel rebar brought complexity and challenges in the real construction. So to overcome this problem, a new hybrid confinement tube, so-called the FRP wrap steel corrugated tube, or FWSCT, has been developed. So previous research conducted by Tan in 2014 and Wu in 2015 has indicated that the FWSCT can replace the steel reinforcement, which significantly improves the flexural and shear strength and increases the ductility of the columns. As we can see here, the tube has inner ribs that can efficiently transmit the axial force between the tube and the concrete core. So the purpose of current study is to investigate the flexural behavior of the FWSCT jacketed SRC columns. Next, I will talk about the test program. So in this study, we prepare 5 specimens. For test number 1, the specimen will be wrapped by 2 layers of CFRP in longitudinal, and then 3 layers of GFRP in hoop. And for test number 2, the specimen will be wrapped by 3 layers of GFRP in hoop. And for test number 3 and number 4, the specimen will be wrapped by 3 layers of GFRP in longitudinal and 3 layers of GFRP in hoop. And for test number 5, the specimen will be confined by the steel tube. There are 2 types of shaped steel that is used in this test. So for test number 1, 2, 3, and 5, the specimen will be reinforced by the shaped steel. While the test number 4, the specimen will be reinforced by the hollow shaped steel. Here we can see the cross-section details of each specimen. From this figure we can see the dimensions of the shaped steel that we use, as well as the inside and outside diameter of the tube. So the specimen information is summarized in this test matrix given in table 1. And these are the material properties that we use in this test. So this figure shows the test setup. As we can see, so the specimen will be settled on 2 steel saddle at location at about 15 centimeter from the end. And we also can see under the steel saddle there will be a spherical steel support to form a pin support condition to allow the rotation of the specimen during the test. And also 2 loading points will be placed at location 45 centimeter from the support. So here is the setup illustration. So we will be using the 500-ton universal testing machine, which will be provided by NCREE. So we also have designed the steel saddle, the support, as we can see in figure 15C. So the steel saddle has been already fabricated. And this is the location of instrumentations. So a total of 22 strain gauges will be placed on each specimen, including 12 in longitudinal and 10 in hoop. And also 5 LVDTs will be placed under the specimen to measure the deflection, and 1 LVDT will be placed at the tip of the specimen to measure the slippage between the tube and the concrete core. So now I will show the process of constructing the specimens. So these figures shows the FRP wrapping process. So start from preparing the steel corrugated tube, then cleaning the tube using acetone, and mixing the epoxy and the silica film to fill up the concave area, then wrapping a segment of FRP sheet. And we can see in the longitudinal segment there is 15 centimeter overlap on its own section. So this is the final result of the FRP wrapping process. Next is the process of the strain gauge installation on the shaped steel. Start from the preparing the shaped steel, smoothening the surface of the shaped steel using fine grade emery paper, and cleaning the area using acetone, and preparing the strain gauge, then plastering and placing the gauge into position, and then we cover the gauge as well as the wire using a few layers of tape. And this is the process of the concrete casting. start from setting up the casting platform, and then we weld the base to fix the position, and then assembling the specimen by inserting the tube, and then we position the shape steel at center position, and then installing the framework for casting the concrete, and we pour the concrete. And we can see this is the final result of specimen fabrication. Next, I will discuss about the moment curvature analysis. So we use engineering software solution or NGSOL software, NGSOL program, to analyze the moment curvature of the specimens. So first we model the cross section of each specimen, and then we input the material data. So the steel is defined as the bilinear curve. Meanwhile, the FRP is defined as a linear curve. And this is the material properties of the concrete. So we define it as a confined concrete. Then this is the output or the result of the analysis. We can see that the specimen with the confined with the steel tube has much higher moment capacity comparing to the specimen confined with the FWSCT. And comparing the specimen with the FWSCT confinement, we can see here the specimen G3G3W has highest moment capacity, meanwhile the specimen G3G3H has lowest moment capacity. After knowing the moment capacity, we can do back calculation to know the maximum load of the specimen. So I think that is all of the progress of this project. Thank you for your attention.
Thank you, Obed, for your good presentation. So I